If you've ever tried reading or writing files, you know that things don't always go as planned. Files might not exist, permissions might be denied, or data might be corrupted. Rust, being as safe and explicit as it is, makes us deal with these errors gracefully. And that's exactly what we'll learn today. So let's dive right in. Let's start with a simple example. Suppose we're trying to read a file named hello.txt. This code works fine if the file exists and is readable. But if it doesn't, for example, if hello.txt isn't in the directory, Rust will panic and print a not-so-friendly error message. So the first thing we need to learn is unwrap is okay for prototyping, but in production code, we want to handle errors gracefully. Let's rewrite this using proper error handling. We'll use Rust's result type, which the file struct's open method returns. Here's what's happening. The file struct's open method returns a result containing either a string and input-output error. If it's okay, we get a file handle. If it's error, we print the error and exit early. Same with read to string. This pattern, matching on the result, gives us total control over how to respond when something goes wrong. Let's take this further. What if we want to automatically create the file if it doesn't exist? We can handle specific error kinds using e.kind and the error kind enum. Now this is powerful. If .data.txt doesn't exist, Rust catches that specific error and creates a new file. If the error is something else, say permission denied, it propagates the error upwards. Notice the question mark operator? It's a lifesaver in Rust error handling. It automatically returns from the function with an error if something goes wrong. This makes your code concise and readable. Let's make a more real-world example. Suppose we're building a simple log writer. We want to append text to a file, and if it doesn't exist, create it. Here, we're using open options to open a file in append mode. If the file doesn't exist, create true ensures it's created. Then we use writeLine to write to it safely. Notice how all I/O functions return a result, and we're using question mark to bubble up errors automatically. In a production system, this pattern is gold. You log actions, and if something goes wrong, like disk full or permissions missing, you get a clear typed error to handle. Now let's talk about handling multiple errors differently. For instance, if we try to open a configuration file, and if it's not found, we create a default one. If it's permission denied, we notify the user. In this example, we're attempting to open and read the file named config.toml, implementing robust error handling with the match expression. If the open method succeeds, the file contents are read into a string and printed. If the file is not found, error kind not found, the program creates the file, writes the simple default configuration string to it, and then exits successfully. If a permission denied error occurs, a warning is printed and the program exits. For any other I/O error, the error is propagated using the question mark operator or explicitly returned, and the main function is set up to return a result to gracefully handle these errors. This pattern makes your app feel professional. You're not crashing, you're recovering, giving users feedback and ensuring the program remains stable. Next, let's simulate a file read failure. Say you're processing multiple files and one fails. You don't want to crash the entire operation, right? Here, we defined a function, readFile, that attempts to open a file specified by its name and read the entire contents into a new string, returning a result containing either a string and input-output error to indicate success or failure. The main function then iterates over a list of file names, a.txt, b.txt, c.txt, calls readFile for each one, and uses a match expression to print the file's content upon success, or print an error message detailing the failure upon receiving an error. This is common in batch processing, backups, or data pipelines. One file might fail, but others continue. This graceful degradation is what makes your Rust programs resilient. Now let's combine all that into a more complete, realistic program. Imagine you're writing a Rust note-taking CLI tool. Every time the user writes a note, it gets saved in a text file. If the file doesn't exist, it's created. If something fails, you handle it politely. We have two functions, save note and read notes. The save note function uses open options to open notes.txt with permissions to write, append, and create the file if it doesn't exist. Then uses writeLine to add a new note followed by a new line with the question mark operator handling any I/O errors. The read notes function attempts to open the file using the file struct's open method, specifically catching a not found error to print a message and return an empty string gracefully, but otherwise propagating any other I/O error or reading and returning the file's contents upon success. Finally, the main function demonstrates usage by first saving a new note, then calling read notes to fetch and print all the accumulated notes, propagating any final errors. See how seamless that feels? Every operation that might fail returns a result. We handle or propagate errors properly, giving users feedback instead of panics. This is idiomatic Rust, clear, safe, and robust. To wrap this up, Rust's vile I/O error handling may feel verbose at first, but it's designed to force you to think, what could go wrong here? That mindset makes your software safer, more reliable, and less likely to crash unexpectedly. Remember, handle your errors, don't let them handle you.